Hello everyone, I am Surendra Jain, Master Teacher in Vedantu. I am presenting you the solutions of JEE Advanced 2019. This is question number 9 from paper 1. This question is taken from the topic ellipse in conic section, one very important topic for JEE Advanced. Let us see what this question is. Define the collections E1, E2, E3 and so on of ellipses and R1, R2, R3 and so on of rectangles as follows. E1 x square upon 9 plus y square upon 4 equal to 1. R1 is the rectangle of largest area with sides parallel to the axis inscribed inside E1. Now En is another ellipse which is x square upon An whole square plus y square upon Bn whole square equal to 1 of largest area inscribed in rectangle Rn minus 1 for n greater than 1. Rn is rectangle of largest area with sides parallel to the axis inscribed in ellipse En for n greater than 1. Then which of the following options are correct? A. The eccentricities of E18 and E19 are not equal. B. The length of latest rectum of E9 is 1 upon 6. C. Sum of areas of rectangles as n varies from 1 to capital N is less than 24. The distance of focus from the center in E9 is root 5 upon 32. Let us see how to solve this question. So we are given one standard ellipse whose major axis is along x-axis and minor axis is along y-axis. And we are supposed to inscribe a rectangle whose sides are parallel to its axis, that means parallel to x-axis and parallel to y-axis. So let us call this rectangle to be A, B, C and D. I can take the coordinate of A as 3 cos theta, 2 sin theta, which is nothing but parametric coordinate of any variable point on the ellipse. The point B can be taken as minus 3 cos theta, 2 sin theta. The y coordinate will remain same because this AB is parallel to x-axis, and x coordinate will be just negative of what it was for A. Why it is so? We can see it by symmetry also, and there is one more reason, please understand. AD and BC, they are of equal length. They are chords of equal length and they both are parallel to y-axis. So one has to be on right side of y-axis and one has to be on left side of y-axis with equal distance from y-axis. So their x coordinate should be same, only difference would be of minus sign. So that is the reason why B has x coordinate, that is minus of x coordinate of A. Okay, similar to this we can write coordinates of C and D. Now sides of this rectangle are, you can easily check, 6 cos theta and 4 sin theta. So the area of this rectangle would be 6 into 4, 24 sin theta cos theta, which I am writing 12 sin theta, 12 sin 2 theta. So the maximum value of this area, which will be actually area of this R1, so let me write this as AR1, will be 12, and this 12 will be when we take theta to be equal to 45. So this will give us the sides of R1 also. Sides of R1 would be, if you put theta as 45, 3 root 2 and 2 root 2. These are the sides and 12 is the area. Okay, let us move forward. Now this blue one is the ellipse and this black one is the R1. Okay, so I have already told you R1 has sides to be 3 root 2 and 2 root 2. Now we want one more ellipse to be inscribed in this rectangle so that its area is maximum. As you can see, En, if I take n as 2, we can read this as E2 and it will be ellipse of largest area inscribed in R1. So R1 we have found, this is black color one. So my E2 would be an ellipse that is inscribed in this rectangle and has maximum possible area, and this maximum area will be possible only if this ellipse touches this R1 rectangle at x-axis and y-axis. Then only its major axis, minor axis will be maximum possible, its area will be maximum possible. And also all these ellipses are standard one, which means major axis is along x-axis, minor axis is along y-axis. Now if this length of this rectangle are 3 root 2 and 2 root 2, then for this ellipse E2 you can see semi major axis will be half of this 3 root 2, so we can write this as 3 upon root 2. Similarly, semi minor axis of this would be half of 2 root 2. I am writing this as 2 upon root 2. Why I am writing? Let me tell you. We were given E1 whose semi major and minor axis were 3 and 2. Now for E2 we have found that it is 3 upon root 2 and 2 upon root 2. So we can see both semi major and semi minor axis has now become 1 upon root 2 times of previous value. Now once again we will be inscribing R2 inside this ellipse E2, and then we will be inscribing E3 inside that rectangle R2 and so on. But every time we can check the values of semi major axis and semi minor axis, they will become 1 upon root times of the previous value. So this E3 will become 3 upon 2 and 2 upon 2 and so on and so on. So this nth ellipse, if we see, it will be 3 upon root 2 raised to the power n minus 1 and 2 upon root 2 raised to the power n minus 1. Okay. Now let us see what options they have asked. So first option they are asking is eccentricities of E18 and E19 are not equal. Now we can see that in every ellipse E1, E2, E3, both semi major and semi minor axis, they are becoming 1 upon root 2 times, but their ratio B upon A is always same. Okay, and it is 2 upon 3. In fact, eccentricity can also be obtained by the formula 1 root over 1 minus B upon A whole square. So this will be root 5 upon 3. Root 5 upon 3. Okay, so A option is definitely wrong. Now coming to B part, length of latest rectum of E9. Now we have found a relation for En, so for E9 also we can find semi major axis. Let me call this as A9, and that would be 3 upon root 2 power 8, and if we solve it we get 3 upon it would be 16, 2 power 4, 16, yeah. And similarly B9 will be 2 upon root 2 power 8, so this will be 1 upon 8, 2 upon 16, 1 upon 8. So length of latest rectum, as there is a formula 2b square, here B9 square upon A9. So let us put these values, 2 into 1 upon 64 whole divided by 3 upon 16. So if we simplify it, we get this to be 1 upon 6. Yeah, 1 upon 6. So let us see what they have given. Length of latest rectum of E9 is 1 upon 6. That is absolutely correct. Now let us do the D part first, because they are asking distance of focus from center in E9 only. So for E9, distance of focus from center, it is always 8 into E. Here in this case it will be A9 times E. A9 we have found 3 upon 16. E we have found root 5 upon 3. So this 3 will get cancelled and we get root 5 upon 16. So the distance of focus from the center in E9 will be root 5 upon 16. They have given root 5 upon 32. So this D is also wrong. Now let us come to C part, which is asking the sum of areas of all rectangles as n varies from 1 to n for every positive value of capital N. Now, as I was telling you, for R1 we got AR1, area of this as 12. Okay, and if we find R2, as it was for ellipse, It will be same for second rectangle also, that its corresponding sides will become 1 upon root 2 times of its previous rectangle. So here area of this second rectangle should becomes 12 upon root 2 square, because both sides are becoming 1 upon root 2 times, 1 upon root 2 times. So area will become 1 upon 2 times. So this is 6 here. Similarly for R3 you can calculate AR3 will be 6 upon 2, that is 3, and so on. Now they are asking sum of rectangles, sum of areas of rectangles as n varies from 1 to n. Let me find sum of all rectangles as my n goes to infinite. Okay, so let me find sum of all the rectangles possible, AR1, AR2, AR3, and so on up to infinite. This is simple GP with common ratio 1 upon 2, first term 12. So the sum here would be 12 upon 1 minus 1 upon 2, which comes out to be 24. Now one very interesting thing. Here sum is coming out to be 24 if we take all possible rectangles up to infinite. Okay, but if we take n, capital N, to be some finite number, maybe very large number but finite number, even then we will not be able to reach this number 24, because it's a limit which calculate all possible rectangles that are going up to infinite. That means what they are saying in this B option, that sum of areas of Rn will be less than 24, is absolutely correct, because what I was getting there was the limit, and here we are looking for all positive integer. So whatever small it is, but it will be smaller than 24. So this C option is also correct. So the answer for this question is B and C. I hope you like this solution. Thank you so much. Stay tuned for the next question. Bye.